Okay, let's do this back titration example. We have 2.00 grams of limestone, and most of that we're told is calcium carbonate, but we have to work out the percentage. That's what this question is actually asking. What's the percentage of calcium carbonate in limestone? To actually work this out, we have two steps. We react calcium carbonate, which is a weak base, with hydrochloric acid, a strong acid, and we have an excess of that acid. We know that it's going to react completely with the calcium carbonate, and there's going to be some left over at the end. And what we do with that excess is that we react that in a titration step, so a second reaction, titration, and then we do all of our calculations from that titration backwards to determine the percentage of calcium carbonate in limestone. So we have to start with the second reaction as far as the calculations go. So let's have a look at that. We have sodium carbonate, Na2CO3, and hydrochloric acid, which gives us, according to this, it's an acid and carbonate reaction, so we get NaCl plus H2O plus CO2. We have to balance it now. So if we put a 2 here, we balance out the sodium, and we need to put a 2 up there to balance out the HCl, and now we're balanced off. Now what we need to look at here is what we have as far as information goes to determine how many moles of the hydrochloric acid has been used. So let's look at both of the things we have in this second reaction. HCl, originally we had 100 mils, and we had a 0.925 molar solution. With the sodium carbonate, we got an average titer of 19.53 mils, and we had a 1.50 molar solution. We can use three of these figures. We can use this one, we can use this one, which came from the titration, and we can use this one, but we cannot use this figure here, because that is the original amount of hydrochloric acid. Remember, some of that has already reacted with the calcium carbonate, which is the first step of the experiment. We're going to end up with three significant figures. If you have a look at this, in our final answer, we're going to end up with three significant figures. Okay, now let's just work with the reactants, as we said. So we've got 2 HCl from this prior equation, and we have Na2CO3. That was just a 1 coefficient. The information we do have allows us to work out the number of moles of sodium carbonate. We'll work that through stoichiometry to find out how much volume of hydrochloric acid reacted with that sodium carbonate. All right, so we have in the titration step. So I've got N equals CV equals, it equals 1.50 times 0.01953 mils. And that equals, just let me get my calculator out, 1.5 times 0.01953 equals 0.029295 mole. Okay, now if we take this over here, we have to divide by 1 times 2, to determine the correct molar relationship, giving us N equals 0.05859 mole of hydrochloric acid. So now let's move on to the next step where we look at the amount of hydrochloric acid that reacted with the calcium carbonate. So let's go on to the next equation now. So now we've done that titration step calculation. Now we move back to work out how much calcium carbonate reacted with the remaining hydrochloric acid. Okay, so we had in this back titration step, the titration step, we had 0.05859 mole. Originally, however, we had hydrochloric acid 100 ml of hydrochloric acid, same molarity, 0.925 molar. So what we need to do to know how much acid reacted in the first step, we need to take this amount of mole here we determined from our titration step from the original amount we actually had. So originally we had N equals 0.925, if we do N equals CV here, that's what I'm doing, times 0.1 litres. Equals 0.0925 mole. So that's how much we originally had of hydrochloric acid. Take from that the amount of the hydrochloric acid that acted in the back titration, which is 0.5859. Equals 0.03391 mole of HCl, which reacted in our first reaction with the calcium carbonate. So that's the figure there that we work on with our new reaction. Let's start a new page. Okay, let's look at the original reaction now. We have our calcium carbonate plus hydrochloric acid and it's exactly the same sort of acid-base reaction we have, except we've got calcium carbonate now instead of sodium carbonate. So we get calcium chloride plus water and carbon dioxide. Okay, now let's balance this one off because we've got to do that before we go any further. We need a 2 up here. And I think that's all we need. So if we now just start with, because this equation's too long for the screen, I'll just work now with the reactants again. We have CaCO3 solid plus hydrochloric acid and we know we have N equals 0.03391 moles here from the last step. We use our molar ratios here, divided by 2 times 1 equals N equals 0.01695 moles. And we can work that out in grams, which we'll do in the next step. Okay, we have calcium carbonate, and we have 0.016955 moles. What we need to do now is find out the mass of calcium carbonate, so we can use N equals M on M. 0.016955 equals M on 40.1 plus 12 plus 3 times 16, which works out to be 100.1. So the mass here equals 0.016955 times 100.1 equals 1.697195 grams. It's okay if you've put less figures in there as you calculate that, but I'm just trying to be as accurate as possible to the end for you. Now, very last step here, we have this much calcium carbonate divided by the original mass of limestone, 2.00 grams, times 100 will give us the percentage calcium carbonate in the limestone, which is 84.9%. That's it.